Hi there. So this is just a video to show you how we analyze the MR1 sensor data offline just using the SD cards. So if you go on this website up here, you'll see some of the STL files that we've modified as well as a download link for the code. So we'll just download this Python file here. Just click download anyway. So we've got that in our download folder. And I generally recommend people to run the Python file off Spider via Anaconda because then all the dependencies and the packages will be pre-installed for you. So if we run Spider from Anaconda, so this is the community version Anaconda Navigator. Just waiting for Spider to open. So this will be the window you see in Spider, and all I'm going to do is just drag the Python file there. We can close that temporary file and hit run. What it will do is load a very simple a file selection window. And from here, we find the data, the DAT files from the MR1 sensor. So I've got one full experiment over here, starting on July 31, very recent, until August 25th. So the first window is select the first day, so this one. And the second window is for the end date file. And you can click the OK button as well. And click consolidate. And so this will generate just a quick view window to look at the data all together. You can use these panels to look at things a bit more closely and move things around. What you'll notice is that each bar is the percentage of it's the activity in each bin, and you'll see that it goes down over time. And this is what we actually want to see with our experimental manipulation. So there'll be another pop-up saying, would you like to analyze another file? If you click yes, these will refresh to blank so you can run more analyses. If you click no, it'll just close everything. So the analyzed file will be in the same folder where the data came from. So this is the HTML file to show those plots in case you wanted to have another quick look. But what it also generates is a CSV file, and the CSV file will have all the DAT files compiled into or all together into one easy to manage Excel. So here we have the 31st of July going all the way down to the end data here. And this is in the same format that's given in the DAT files. What it does add is an extra column at the end, and it converts these activity values, which range from -1 to +1, just into percentages. So from here, what we generally do is analyze data from within Excel. We haven't come up with any other ways to automate this any further. So here's an example of that same data analyzed in Excel. So one thing we do is we feed in a manual midnight time, and we create two extra columns. The first one will combine the date and time columns, A and B, into one. And the second one is a subtraction. And this will give us the days of the experiment as it goes on. And the time of day will be as fractions of the day values. So we know that our light cycle changes from 6 a.m. 6 p.m. and the dark cycle is from 6 a.m. to 6 p.m. And so midnight would be smack bang in the middle. So we manually adjust it and add 0.25. And so we know that if the data falls between 0.5 and the next full number, that is the dark phase. And for example, if it's from 1 to 1.5, that would be the light phase. And so we will generate a little table like this, so we can see our data across different weeks and see the changes in the total activity in the light phase and in the dark phase of each day. And this part can be a little bit tricky because the dates here are given as our time. So this is the time that would be logged in our lab books at 9 a.m. Whereas these won't exactly be matched up. The dark phase will be matched up with this day here, but obviously there'll be some crossover in this light phase. And so we do a simple SUMIF calculation formula in Excel to find the activity we want within a specific range, and we're simply splitting the data into 12 hours, lights on, lights off, which would be 1 to 1.5, and 1.5 to 2 for this particular day. And that would continue on over our 3 weeks. And so the SUMIF formula essentially looks for the values within the activity percentage that fits within the provided range 3.5 to 4, and it will sum these. So you can easily adjust it into an average, and you can adjust these ranges if you wanted some more smaller windows of analysis. So you can see that if we average our 3 weeks of activity during the light phase, we get a gradual decrease, which is in line with the manipulation that we have done here. So I hope this has been helpful. I know that this part, the subsequent part of the analysis, is a little bit dependent on how you want to use the data and what you want to pull out. I'd be interested to hear if anyone else has other ways of doing this that can improve the way we do things. That's all. Thank you.